Good morning. I hope you're doing well. I'm doing very well. This was a good week. There was lots of useful learnings that happened, and I finally did some fairly important things that I really should have done a long time ago, but they're actually done now, so we're good. Of course, I will get to what those things are at the end of the stream for those things. But first, we need to figure out where Jugglebot's origin actually is. This is a fairly important question. So last week we encountered the issue where we have a discrepancy between basically the context of this from last week, if you don't remember, was that I have a retroreflective ball that my motion capture cameras can see, and I wanted to get this so that the platform of Jugglebot could move around and position the hand directly underneath the ball so that when we drop the ball, it lands in the hand, and then the hand can take over and try to actually catch smoothly, however we decide to do that. But to get this positioning to work, I had to have an offset, basically, of saying okay, whatever position you think the ball is in, it's actually 70 millimeters to one side and 4 millimeters to the other side. That's not very good. Especially because one of the offsets was 70 millimeters, and that's a large amount. And yeah, definitely concerningly large. So I spent a bit of time thinking about what could be causing this, and one very likely candidate is that it is because the platform cannot actually move itself to where it needs to be. So the only way that I'm able to figure out that there is an issue here is that I have a ball in this. When I was doing these measurements, I had it on a tripod that was just kind of standing there. And then I also had a ball in Jugglebot's hand, and I could just see where the two of them were and whether they were positioned in the right spot or not. Now, one way that they could be off of each other is that the ball position that's being read is not correct. But a second way that it could be wrong is that the platform itself is not moving to the correct spot. So we're telling the platform, hey, move over here, but in fact it's actually moving slightly over here. And this was something that came up, I believe it was last year, it was a while ago in any event, where someone found a paper that basically showed that when you're building a Stewart platform, which is what Jugglebot's kind of based on, if the platform is slightly off by just a very small amount on any of the joints or even all of the joints, if those positions are slightly off of where they're actually supposed to be, then when you move the platform around, it actually can, and often does, end up not exactly where you think it should be. So if you make all of the legs extend out to whatever length to get the platform to be over here, it could actually be over here with this slight tilt or something wacko like that. And so that's a very likely candidate in my mind of what's going on here, especially because all of the parts that make up Jugglebot are 3D printed, and that is not exactly known for super high reliability. Or millimeter or micrometer even correct precision. So yeah, I think that's a pretty likely candidate of what's going on, but it's not the only candidate. So it could also be something else. For example, I don't know for sure that the Jugglebot's origin is where it actually should be. So to give some context for this, what is going on here is currently there are 6 markers on Jugglebot's base. There are these little spheres that you can see around here. So there's 3 on this side and 3 on this side. And those marker positions are being tracked by the cameras around my room. And then those positions are being sent over to Jugglebot's computer, where I have told Jugglebot's computer where these positions should be with respect to Jugglebot's origin. So this is the origin of Jugglebot right here. I'll explain in a sec why that's where it is. But yeah, I've told Jugglebot's computer, okay, this marker with respect to this origin, I can just measure it on CAD here. I can take up this measure tool and say the center distance is this. And I can take this center distance and then it will figure out, then it will know exactly where that marker is supposed to be. Then the next step is to say, okay, we've got these known positions of where the markers are supposed to be. We've got this feedback, sensor data of where the markers actually are. Let's map these to overlap each other, and then once they've overlapped each other, we can know where Jugglebot's origin is. because I've told it exactly how far all of these markers are away from the origin. So then we should be able to say, okay, yep, the origin is here. Should work. But I've never actually tested this. I've never actually confirmed that where Jugglebot's base origin is according to the computer is where it actually really is. And so I figured, okay, maybe it's time to actually check this assumption that this is actually working correctly, but it was a little bit tricky to do this because if you have a look on Jugglebot's, if I can get to the right camera, on Jugglebot's base here, there is that little box in the middle is where all of like the power connections come through. So in here, this is all just like the high voltage lines that go out to ultimately to all the motors. And somehow, when I changed over from SolidWorks to Onshape, I lost that file. I don't know where that file went. I don't know what, it's just gone. I am so confused about this. It's just disappeared, which is a little bit annoying because that piece obviously has a known height, and that is also directly in the middle of Jugglebot, directly underneath where the origin is supposed to be. So that's why when we look at this, like this origin is kind of just like floating up in space, and that's above this like power hub thing. Also, I said before that I'll explain why that origin is where it is, and the reason for that is because it's very helpful to have the base of the origin be at like the lower connection point of where the legs attach to the base. So you can see here, if we take like a side view, this is directly in line with these base nodes. It's just very helpful for the inverse kinematics to have that be the case. Yeah, it could be lower. I mean, we can talk about this in a bit. But yeah, that's the reason why it is where it is right now. And of course, everything in the code is based off of that being the origin. So that unless I change stuff in the code, that has to be where the origin is. And I can definitely change that stuff. But again, we can talk about that in a sec. Oluwafemi says, haven't been on the channel in a while, but happy to see the project is still going strong. Definitely is. It is better and better every week. But it's also a lot more complicated than I was expecting it to be. Yeah, it turns out it's not easy to build a robot that can juggle from scratch. But we're getting there. We're getting there. Yes, so the reason why it's annoying that I lost that file is because I don't actually know how tall that piece is. My thinking with this is that, okay, if that like mapping process that I described before is working correctly, then I should be able to just put a marker at Jugglebot's origin, where I showed you on the CAD just then. We should just be able to put a marker there and then read out its coordinates in the Jugglebot base frame, which uses that as the origin. And we should get the position as being 0, 0, 0, right? It should be directly at the origin. So I was like, okay, cool. I can just print a little thing to hold a marker at that spot. Then I was like, oh crap, I don't have that file. So it's a little bit sketchy, but I've had to just like measure how big it is, like how tall it is and how big that hexagon is. And then I've printed off this little standoff thing. So I believe this should put the origin, this should put this marker very, very close to this origin point here. It may not be exactly on, but it should be pretty damn close. Within 5 millimeters, definitely. So let's put this there and see if that actually is at the origin. So let me find my right camera view. Nope, this one. Yeah, I made a camera view just for this. So if I start a new Qualisys recording, you can see here, this is now streaming, and you can see some stuff that is a bit of a spoiler for later, but I can't really hide it very easily, so you can see it. But yeah, so as I've got my conductor's wand from before, and as I wave this around, you can see that marker's moving around. And now if we start up the Mocap interface, this will do that transformation that I described before, and now it's putting all unlabeled markers into the body frame. So you should be able to see this text here. I might actually be able to make it a bit bigger. Yep. So now as I wave this marker around, this is not reporting the marker's position as far as the cameras can see it. This is reporting the marker's position in Jugglebot's base frame. So if I put this marker right at the origin, it should be 0, 0, 0. Also for reference, the first 3 digits here are the position in millimeters, and then the last digit is the residual. So like how big of an error are we expecting? How big of an error are the cameras like allowing for, essentially, or like, yeah, anticipating. I can also move this around and I can have 3 markers. So as I move these 3 markers around, we can see all of them are there. So let's see what happens when we put this at the origin. Actually, I want to sit over this side. So if I line this up, of course, it's not exact because I can't measure properly, it turns out, but I can get it pretty close. And it's definitely not like snapped in there or anything, but I can line it up as close as I can. And so what do we see? We've got, in the X, we are 4.7 millimeters off, which is not terrible, but in the Y, we're 67 millimeters off. And remember before when I said how big of an error we were getting on the ball position? It was, actually I can bring it up. Let me have a look, just so we can know for sure. Oh, it actually is here. My offset was 4.5. Let me hide this so you can see it. Yeah. 4.5 millimeters in the X direction and 70 millimeters in the Y direction. And that is pretty damn, I mean, I guess there's the negatives don't both line up, but that's pretty damn close to how big of an error this shows. So in my mind, this is definitely contributing pretty significantly to the error that we saw last week, which is a bit annoying. Yes. But so one very interesting thing about this that I discovered while I was playing around with this is that if I cover up certain markers of Jugglebot's base, that prediction actually becomes more accurate. So if I cover up these 2 in particular, if I cover up those 2, then suddenly, actually that origin gets very close, like within a millimeter. Like, but now I'm giving it less information, but it's more accurate somehow. Like, what if I cover 3? That's even better. Why just giving it less information make it better? Yeah, it's very confusing. Yeah. So this led me into a big thought process of like, how can we actually improve this? So let me stop these things from running. Okay. Let's put that back over here. So is Jugglebot's origin where it should be? The answer is decidedly no. Oh, I should have done this first. Let's see, we already saw. Oh, I'm not on camera. So, yes, one of the things that I have realized, I kind of knew about this a little while ago, but I didn't really spend that much time testing it out because I didn't immediately see how I could apply it to what I'm doing. But something that the Qualisys software can do, the motion capture software can do, is exactly that transformation process that I'm currently doing in my code. So what I described before about we're receiving those 6 marker positions, those are in the camera frame. So that's with respect to whatever origin I set when I last calibrated the cameras. That mapping process that I'm doing, that can be done in Qualisys. So you can give the Qualisys software, it's called QTM, you can give that software, you can basically take a recording of an object and then say, this set of markers, this is a rigid body. These will always go together as a rigid body and they will like stick and move together. And then in all future recordings, if you have that rigid body kind of like turned on, then it will try to find those markers, and if it can find at least 3 of them in my testing, I don't know what the actual like rule around this is, but in my testing, if I have at least 3 markers visible, then it will fit that rigid body to those 3 markers that it sees. So for example, here we can see on the right hand side here, we can see I have 6 base markers. Those are the ones that I showed in the CAD before. We also have 11 platform markers, which I'll talk about a little bit later. And here we can see this unlabeled one is the one that is currently still at Jugglebot's origin. Yes, so this the fact that this origin, this marker is at where Jugglebot's origin is supposed to be, but we can see that that is very offset from where Qualysis thinks the base origin is. And this is why I kind of got a bit turned off of this, because I can, for example, we can have all of these rigid bodies be fit to the marker sets that we've got that are visible. And then further to that, we can also then send all future coordinates with respect to any origin of any rigid body. So for example, if we go into these settings, if we're in the tracking one, in an ideal world, if we could get Jugglebot's base to be tracked so that its origin is where Qualysis puts the origin, like the centroid of those markers, then we can have all future, or any other markers that are being recorded, they can all be transferred with respect to that origin. I'm pretty sure. You can definitely do it for other rigid bodies. So for example, the platform, right now it's being presented in terms of the global origin, but we can very easily just put this in terms of the base origin. And now, when we do this, all of these platform coordinates that we get, these are with respect to the base's origin, which would be so much easier. This means that I don't need to do any of this transformation stuff. I can just have all of the coordinates come in straight away in Jugglebot's coordinate frame, which, yeah, would save me a lot of work. And I am certain that the implementation that is done in this software is much, much more efficient than what I am doing on my end, just because that's the way these things work. I'm not very good at code, and these guys have made this whole software, so they presumably are. But this gets a bit tricky because we need to make sure that the centroid of the markers that make up the base are exactly on the actual Jugglebot centroid, which is a bit, yeah, easier said than done. So yeah, in an ideal world, we can let QTM do all of these transformations so that we don't need to, which would be fantastic. It almost deletes an entire node in my ROS network, which is great. I want to kind of make things as simple as possible. But yes, this raises the question of where do we place the markers to achieve that centroid in the right spot? Part of the reason why this is tricky is because that centroid is so high up. Oh, sorry, like the origin point that we want Qualysis to use is really high off of the base. So we could put a bunch of markers all around, like if we filled in all of these holes around here, like this pattern of holes is symmetric. So we could just like fill in all of these external ones and make sure that the markers are high enough up so that they are exactly in line with this origin here. And then the centroid of those would be exactly Jugglebot's base, which is great. Cool. We can just put however many markers we want. We can even do 12. We can put 12 markers all the way around in the same plane so that they are in line with Jugglebot's origin here. But it's not that easy. For one, I don't really want to have the markers be that high off the ground because A, it's going to look bad, and B, it's going to be way, way easier for me to kick them and break whatever is holding them up. I'm not a big fan of that. Secondly, and more importantly, if you have a rigid body and the way that the markers are laid out is symmetric, the software won't know if that body is oriented in the correct way. So I should have made a demo for this, but I didn't. But if you imagine you have a triangle and you have 3 markers here, if it's all that the cameras see is just the position of those 3 markers, it doesn't know if the body is oriented this way or 120 degrees around or 120 degrees around the other way. Like, it can fit that many different ways. And especially if all of the markers are on the same plane, then it can just flip the whole thing around and then suddenly Jugglebot will be in the ground as far as the software is concerned. So you need to make sure that the markers are positioned in such a way that there is no other orientation that you can fit those markers into that is incorrect. It has to be like a unique layout of markers. And this was a whole rabbit hole to go down into. But I think I figured it out. So where should we start with this? So my first thought with this is that let's get rid of the markers that are there right now, because those ones are no good. Though the centroid of these 6 markers is like not even close to the centroid, to where Jugglebot's origin is supposed to be. Like we can see on here, it's miles away. And that makes a lot of sense because those markers, this might be a bit easy to see. No, spoiler. This might be a bit easy to see on here. If it will load. I'll have some water while we wait. My computer's been struggling a lot lately, I've got to say. I don't know why. Anyway, whatever, I'll show you on here. No. Yeah, it makes a lot of sense that the centroid of those markers is so far forward, because if we have a look at it from above, it can be a little bit tricky to see all 6 of them at once. But they're very like forward leaning. And the reason why I made all of those markers towards the front is because the back of Jugglebot is not really visible to the cameras. So it's kind of hard to see where all the cameras are, but you can see one of them there. But they're all, like 3 of them are in front of me here. So they're all kind of like facing down this way. So I was like, okay, if there's not much point putting the markers right at the back because the cameras can't see them. But I didn't realize at the time, or in the past, that you can have a rigid body defined in the Qualisys software, and it doesn't need to be able to see all of the markers. It only needs to be able to see all of the markers that one time for that first initial recording when you tell it, hey, these markers are this rigid body. So it's plausible, and I think that this is the correct way to do this, is for me to put markers all the way around, wherever they need to be, which we'll talk about, slide Jugglebot into a position where all of those markers can be seen by at least 2 cameras. So it's in a position where I'm not going to be using it normally, but it just can be visible. Honestly, I might even need to like prop it up or like tilt it around a bit weirdly. We'll see. But then when it's in actual use, there might even be like 6 markers there that are not visible at all because they're just hidden behind other bits of Jugglebot. But that doesn't matter, because as long as the front ones are visible, as long as 3 of them are visible, then it will be able to fit that full rigid body and it will say, yep, the centroid is where it's supposed to be. So yeah, first piece of learning is that we can and should put markers the whole way around. And this is where I kind of started with this thinking process is, okay, if we want the centroid of those markers to be at Jugglebot's origin, they need to be symmetric about this like XY plane. So they need to kind of like, yeah, have some level of symmetry. But that symmetry is not ideal for the purposes of fitting the rigid body to those markers. Because if we have too much symmetry, then the thing's going to be able to twist around in all kinds of weird ways, and it will still be a valid solution for how those markers can be oriented. Which is a bit of a problem. So we definitely need that symmetry, but we don't want too much symmetry. And after a bit of thinking about this, the solution that I have come up with is to do this. Where, let me make the, now you load. Let me make the difference here a bit bigger so it's a bit easier to see what's going on, because right now it's kind of tricky to see. Not 500, that's a bit tall. Let's go 50. So, oh, actually I do kind of want that. It's a bit easier to see when we don't have to deal with the whole robot in the way. Now I'm gonna wait for this to load again. Come on. While that's loading, I can't even see if it's done or not. Why is this so slow? All right, I guess we're gonna have to do it on here. So what I've come up with is a solution that does have rotational symmetry. So we can see all the way around these markers. I really don't like it on with the Jugglebot in the way. Maybe I just hide it. Yeah, that works. That's so much easier. Okay, let's go full screen. So yes, what I've come up with is a solution that does have rotational symmetry here. So you can see all of these markers are oriented as though they're around a circle, or 2 circles, the whole way around Jugglebot. And so you might be thinking, okay, this is fine, but can't we have this oriented 120 degrees around and in both directions and also flipped? If they were all on the same plane, then yes, we could, but they are not. And I spent a fair bit of time thinking about this, and to be honest, I don't know what the best way to do this is, but a solution that I came up with is to have one for each of these pairs. One of them is higher and one of them is lower. And if we had all of the like high points being, like for example, you can see like these 4 around the back of Jugglebot have the tall one being on the inside. If we had all 6 of them with the tall one on the inside, then it would be okay. It would not be able to be flipped around like vertically, but it would be able to be rotated 120 degrees in either direction, and all of the markers could still fit, but they would be oriented wrong. So that doesn't work. But if we have at least one, I think you can do it with one, but it's less robust, which I'll talk about in a little bit. So what I've done now is I've got 2, where 4 of them have the tall one on the inside, and 2 of them, these 2 closest to the viewer right now, which is at the front of Jugglebot, have the tall one further away from the center of Jugglebot. And as far as I can tell, this is a pretty robust solution. And what I mean by robust is that this, as it is right now, does not allow for any other, like if you take these 12 marker coordinates, you cannot fit these to this structure in any incorrect way. Big asterisk here, which I'll try to remember to talk about. Oh, actually, I may as well just say it now. So the big asterisk here that this depends on is that we are using a right-handed coordinate system. Now this is getting a bit into the weeds, but I think it's important. So we can see here, this origin that I've got here, and basically any origin that you will ever see, or any coordinate system that you'll ever see anywhere normally, it's called being right-handed. And the way that I remember this is if you stick your thumb in the direction of the z-axis, which is blue, then as you twist your fingers around, you will encounter the x-axis first and then the y-axis. There's almost certainly better ways to remember this, but that's how I remember it. So yeah, stick your thumb in the direction of the z, and then you'll hit x, and then you'll hit y. And that's if you use your right hand. If you use your left hand, that's not going to work because it's a right-handed coordinate system. But that's not the only way to do it. You can just as validly have a left-handed coordinate system, and everything still works fine, as long as you make sure that you are consistent with that. Now the tricky thing with this is that this layout of markers that I've got here, as far as I'm aware, it can be, if you use a left-handed coordinate system, then this whole thing can be inverted, and it does, like you can fit the markers to being in the correct layout with this with this mirrored coordinate system. And I'm not certain that QTM, the motion capture software, forces the use of a right-handed coordinate system. I'm pretty sure it does. Like, why would it not? Because who the fuck uses left-handed coordinate systems? But I'm not certain, and yeah, I need to check this. Thankfully, I actually have a meeting scheduled tonight with one of the QTM engineers to talk about this whole process, this whole pipeline of like getting camera data over to Jugglebot's computer. So I'm going to ask them in that meeting, hey, is a left-handed coordinate system a thing that I need to worry about? And if it is, then I'm going to have to, I don't know, figure out a different layout of the markers. But I'm just kind of fingers crossed at the moment. They don't say anything in their docs about right-handed coordinate systems or anything. So I'm just going to assume that they can only do right-handed for now. Now, for me at least, it's not immediately obvious that these markers cannot be mapped any other way. Like, it's really hard to think about this, in my opinion. I tried one way that I thought of, like, that I could maybe test how unique this orientation is to make a copy of all of these. I made a copy of all of these marker little holder things and made sure that they're all like locked in their position, and then I just moved them around in CAD and just oriented them, and I was just trying to see if I could like rotate it or twist it around or do anything to get them to fit. And I couldn't with that test, but like that's not a super rigorous test. Like I can't test all rotations just because I'm a human and I don't have infinite time. John says, no one uses left-handed coordinate systems except for undergrads by mistake. Yeah, I think that's probably true. And the Soviet Union, really? Wow, Emmanuel Mess says, I did not know that. That's interesting. Just got to be different, don't they? That's usually, I'm surprised the US doesn't encourage it or just like left foot coordinate system or something stupid like that. So yeah, for me at least, it's not immediately obvious that this solution is a properly unique one. And even beyond that, it's one thing for it to be unique if all 12 markers are visible, but if not all 12 markers are visible, then maybe there's ways to map this out where it can be incorrect. Like for example, an easy example of this is if these markers are hidden, like for example, if I'm walking around and we can't see anything, and if these markers are hidden, what was it, that one? If all of those are hidden, and if we can only see these 4 markers over here, then we can fit that rigid body, because we only need 3, as far as I'm aware. I've tested it with only 3. We can fit that rigid body, but we don't know if the rigid body is the way that it should be, or if these 4 markers that we can see are actually these ones over here. It could just as well be those ones over there, we just don't know. So if all 8 of these other markers are covered up, then we can fit an incorrect solution to this. And that's one example of how that can be done. What if we cover up a different 4? What if we only cover up the top ones? What if we only cover up a couple? Like, there are so many permutations possible here of like different things to be covered up. And I was thinking like, okay, this solution does feel pretty good to me. But I don't know how good it actually is. Like, what if I just walk past and I cover up just the wrong markers in just the wrong way, and then the whole thing flips around and then suddenly Jugglebot destroys itself? That shouldn't be possible because I have many, many guardrails through the Jugglebot like moving pipeline to stop it from moving the legs in a way that will break them. But I've never really pushed them. I mean, I pushed some of them pretty hard. I have faith that it wouldn't break itself, but it would be a very uncomfortable position for Jugglebot to be in. So I did the only reasonable thing to do, which was to make a software to figure out how robust these things are for me. And when I say I did it, I mean obviously that ChatGPT and I collaboratively did it. So let me show you this one. Emmanuel Mess says, can you use a sort of memory that prevents the coordinate system from jumping around? Yeah. So I actually did mention this last week about having, I've remarked that when I cover, like when I walk past Jugglebot, and because the cameras are in front of me here, if I walk past, then I'll be covering up a bunch of the markers on the base. And I noted that when I do that, I often see where Jugglebot's computer thinks the base is. That often jitters around a bit. And I suggested having some kind of like low pass filter on this so that it can't move by too much. And yeah, I think that would be a good idea. I think it would be. I do like that idea, but I don't know how. If I'm doing this mapping myself on Jugglebot's computer, then it should be relatively easy. Like, which is what I'm doing now. Then it should be relatively easy for me to put that filter on so that that like base coordinate system can't move too quickly. But I don't know how that would work if I'm getting all of the streaming data from the cameras themselves, because they're just like feeding me that data. I don't know. I'm thinking like in an ideal world, I won't actually even need to receive the data of where the base markers are, because I won't need to do anything with it. Because if I can get all of the cameras, if I can get this software to just report all marker positions with respect to Jugglebot's origin, then I don't need to do any. I don't even care where the base is with respect to the camera system. I don't care about the camera system. It doesn't matter for me. So I wouldn't have any control at that point of where the system thinks Jugglebot's base is. Yeah, but I will talk about the shifting of the base. Well, actually, I keep saying I'll talk about things later, but I feel like, yeah, they just come up. Yeah, one thing that I think will be advantageous about this new system is that currently I only have 6 markers on the base. And as I walk around, if I cover up one of them, then that's like, what, a sixth, like 18% of its information about where the base is. But if I have 12 markers down there, even if only like 8 of them are visible, if I cover up one, then that's much less damaging to fitting that marker set there. So I think that just by having more markers, I think that this should be way more resilient against just like random fluctuations. I think. We'll see. We'll see what happens. John says, I think you should make the markers more asymmetric and just embrace the coordinate system transform. You are going to end up some amount of offset no matter how perfectly you do this. Yeah. So I do, at the moment, I'm expecting the only offset that we need to have is in the Z direction. So where I have the markers laid out right now, like I'll show you what it actually looks like. So this is with very tall standoffs, but they're not actually that tall because they don't need to be. In reality, they're only this tall. So it's very hard to see that there's actually a difference in height and like how it's laid out. But this is how I'm proposing they are, and I've actually already printed them off and have got them all here. So they're all ready to go on. This is all of my markers of this size. I have just the right number to have my conductor's wand and my origin thing, and these 12 and the 6 on the base. It's a perfect number. Of course, I'll be harvesting the 6 from the base once I swap over, but yeah, I thought that was good. But yeah, so the height of these is obviously significantly lower than where Jugglebot's actual origin is. And this was another important thing actually. So I needed to make sure in my mind that, where's that going? That the average XY coordinates of these is at like 0, which it is with these 6. And secondly, I needed to make sure that the height was at least like a known value, which is why I didn't want to have like random heights for all of them. Like if one of them was super tall and one of them was really small and another one was like kind of in the middle, then it would have been really annoying to figure out where that centroid actually is. But this way, with all 6 of these marker pairs, they are all, one of them is low and one of them is high by the exact same amount every single time. So the average of all of these is going to be smack bang in the middle, which will be like really low down. It'll be like down here somewhere. So I'm expecting to, I'm hoping that in the Qualisys software, I can tell it to, I can like apply this offset in the software. I'm really hoping I can do that, and that's another thing I want to ask them tonight. If I can't, then yeah, I will need to take in all of the base coordinates and then just offset everything by like 30 or 40 millimeters or whatever it happens to be. Yeah. But I really want to get the QTM software to do as much of this as possible because their implementation is definitely going to be so much better than mine for doing this. So I really wanted to try to make the most of that. Yes, so the question is, how robust is this orientation actually? And how robust is any orientation? If we have a square and we cover up one of the markers, how many different ways can we fit that around? So I had ChatGPT help me make some software, and this is available in a link in the description of this video if you want to check it out. It's on GitHub. This one, we have marker layout analysis node. And here I've put in, these are the marker positions of these markers on Jugglebot's actual base. Like these guys. I did the same thing as before, basically just measured from here to here for each marker, and then took this, the center distance from the markers to each other. Yeah, so these are all of those coordinates. They're just what they are. And what this software does, what this script does, is it will first check whether or not this position is actually unique, and if there's only one way that this can be fit. And we can allow or disallow reflections. So right now it's false, but I'll show you what it looks like if it's true in a sec. And then if it is the case that this layout is unique and there is no other way to map those marker positions to that rigid body, then it will go through and progressively eliminate one marker at a time and different markers, like it will eliminate like each marker at a time, and then check if that new combination of markers is unique or not. And it will do that all the way down until a minimum subset size. So I've limited that to be 3, because once there's fewer than 3, the software can't even fit the rigid body anyway, so it doesn't matter. We always need at least 3 to be visible. And we have a tolerance for how close the mappings need to fit, and a mean squared error for the same thing. Well, a similar thing. And if you run this, it will check through all of our different subsets. And then once it's done, it will plot the results. So the first thing that it told us is the full set is unique. So this is, oh, my camera's in the way. So this is telling us, oh, you can, maybe if I move it up a bit, you can see it. Yeah, full set is unique, there you go. Proceeding to search all subsets. So this is saying that, yep, we've checked for the original 12 markers and no amount of rotating can mistakenly arrange them. So then we'll check through all of them. And we check through, if we remove one marker, what happens? Let me just get rid of me. If we remove one marker, then do we have multiple solutions? In this case, no, there are no ambiguous subsets if we remove only one marker. So this is good. This means that if I'm walking past Jugglebot and if I cover up one marker by mistake, we still have a fully unique solution. Same thing goes for 2, same thing goes for 3, same thing goes for 4 and 5. But once we get to 6, once we cover up 6 markers, then let me actually, sorry. That should be a bit better quality. And I'm realizing I can actually put me back. But I can put me up here. Yeah, once we get to 6, so once we've covered up 6 markers, then there are 2 ambiguous subsets. So there's 2 ways that this can be wrong, and only 1 way that it can be right. So let's have a look at what, yeah, that's this one. So that we have a plot that shows us what these 2 incorrect solutions are. And it's a little bit tricky to fit, like I don't know how to color these coordinate systems. So we have 3 coordinate systems here. One of them is the original coordinate system, which are the ones with slightly longer arms. That's like the actual, like Jugglebot's actual real origin. Then the one that's in the same colors but is a bit shorter is the origin of where like the subset of markers is. And then the other one, which is like the cyan and like a light orange and a light green, that is like the origin of the incorrect solution. So we can see what way the incorrect part is incorrect, if that makes sense. And then around the sides, we can see the black dots are the remaining markers, the ones that are not covered up. And then the ones with the little cross are where the markers are supposed to be, but they are now covered up. So this is showing us if we cover up all of the lower markers and we have only the upper markers remaining, then it is possible that we can fit an incorrect solution to this by flipping the whole thing around, which in my mind kind of makes sense, because if we come back to here, we can see that there's a symmetry, like I've forced there to be a symmetry about the, like in the XY plane. So, and the only kind of asymmetry that I've got is with the heights. And so if we cover up all of the ones that are the same height and we're left with like only the upper ones or only the lower ones, then we can kind of flip this thing around and we need to position it, we need to offset it just a little bit, and that we can get that incorrect solution. And so that's what both of these are. So one of them is if we cover up all of the upper ones, and one of them is if we cover up all the lower ones, the other way around to what I just said. But yeah, so those are both valid. I'm not really that worried about this failure mode though, because I don't see any situation where I'm ever going to be covering up all 6 upper or lower ones by themselves. Now, there's an interesting thing here. So when I saw this, I was like, okay, cool, like that is what it is, I guess. I'm not that worried about it. But I was thinking, surely if we can get incorrect solutions for covering up 6 markers, surely this means that if we cover up 7 markers, like if we take one of these markers that's remaining, so we've got like, in this case, we've got all of the upper ones are remaining. If we cover up one of those, surely we can get the same mapping. Like surely once there is an incorrect solution possible for a certain number of markers, removing more markers from that will like keep that incorrect solution as like a valid solution. But it turns out that's not actually how it works. So we can see that was with 6. If we have 6 markers covered up, then we have 2 ambiguous subsets. But if we cover up 7, we suddenly, again, have no ambiguity. We only have one solution. And to me, that's not that intuitive, I think, but it's how it works. And maybe one day I'll have a good explanation for this, but at the moment, right now in the I made it make sense for myself yesterday, but I'm not really in the thinking mode right now, so I can't recall that. But yeah, it's very interesting in my opinion. But then if we keep going further, if we have 8 markers covered up, then we have a lot of different solutions. And remember, this is what I described before. If we're looking at this, if we have all of like these ones and these ones and these ones and these ones covered up, then what I described before about like we have these 4 remaining, we can rotate that around. That is covering up 8 markers, but it turns out there's 14 other ways that we can cover up 8 markers and still have like some amount of rotating being possible. And if we want to see what those look like, we can. Because there's a lot of them. And to be honest, I have not really gone through all of these and like had a careful look at them. If you want to, as I said, the code is on GitHub, so you can just run this yourself. And you can test any different marker combinations you want. Like you can put in a square, you can put in literally whatever you want. And see how unique those positions are. But yeah, the TLDR is that once we cover up 8 markers, shit hits the fan. So we really don't want to do that. So I think this is the one that I was describing before. It's running a bit slowly with all of these plots open. But yeah, there's a lot of them. And so yeah, we really don't want to be covering up 8 markers at a time. Yeah. So I quite like this software. It's very good. Well, this script. I'm a big fan. It took a little while to make, but in my opinion, it works really well. And I'm pretty sure it's working correctly as well, because if we, let me just give you an example. If I, actually I said before I show you that, I'll show you what happens if we allow reflections. So we get here, the full set is non-unique. So this means if we allow reflections, then we can, so this is a left-handed coordinate system, then we can get all of the markers to fit properly. It's literally the exact same thing, but we split it down. Let me re-show these. So if we are allowed to have a left-handed coordinate system and we orient it this way, this is perfectly symmetric, no, this way. This right now is perfectly symmetric about this midline here. Everything is identical. So if we can have a left-handed coordinate system, then we can just mirror this whole thing and suddenly it becomes valid. And that's why we see the 2 Z coordinates line up, the 2 Y coordinates line up, but the X is in the wrong direction. And you can see if we apply the test that I had before of the right-handedness, it does not apply for the, like, I don't know, what is that, salmon, lime green. I think it was like coral blue. I think they're all coral something, but yeah. This feels like a least squares problem. Honestly, that's probably involved in this. To be honest, I would have a hard time explaining how this code does every step that it does. There's some pretty wacky stuff in here. There's like cabsh. I don't even know how to say that word. Where is it? Cabsh? Cabsh? I don't know. It works. Yeah, this is good old ChatGPT stuff. But so it's very likely that there is. I agree that like least squares feels like a. I mean, there's a like we use mean square error, and that's kind of related. But yeah, it's definitely like just testing a whole bunch of things and like seeing what fits. So one of the tests that I've done to see if how like legit all of this is to just like change one of the marker positions and see how that affects things. And so for example, just then I just changed one of the markers from like 300 to 3. And we can see now there's only one way that we can do the covering up 6 markers. So we can see this is the one that I moved. Hopefully you can see that little X just there. This one is not where it is supposed to be, but still if we cover up all of the ones that are the same height as that one that I changed, which looks like all of the lower ones, then we can still keep all of the upper ones exactly the same as what we had before. We still keep all the upper ones and we can still rotate things around. It's good to see you, Stormy. That's okay. Yeah, it's good to have you here. Yeah, so in my mind, this is a good, it's obviously not like proof that it's working correctly, but like it's a good indication that it is. And then interestingly, if we have that marker in a more unique position, we will have less ways that incorrect solutions can arise. So now we only have 10 solutions when we cover up 8 markers, whereas before we had 15 solutions. So yeah, definitely adding more uniqueness is a very good thing. And honestly, like we could definitely have a layout of markers here so that there's no way to have incorrect solutions all the way down to 3 markers. We can definitely do that, but it's going to be really, really hard to do that, making sure that the centroid is where I want it to be, which is at Jugglebot's origin, or at least in the XY. So yeah, it's a lot of like balancing different things. The end result is that I feel pretty good about this current layout. I'm pretty happy with that. As you can tell, I haven't yet put them on Jugglebot because I was just printing them out yesterday. But my plan is that after the stream today, I'll load them all on and then test with the little centroid finder, and hopefully, fingers crossed, this will be at 000 or thereabouts, as close as I can line it up. Yes. Just because I was looking over there. Oh, actually, no, I'll talk about that later. Yeah, cool. So I feel pretty good that the markers now will be in a pretty good position, especially with all 12. Like I should be able to walk past and cover some things up and it should be fine. As long as I can get Jugglebot in a position where all the cameras can see all the markers at least once, just so I can do that initial recording, then we should be good. Hopefully. We'll see. Yes, so where to place the markers, we already know. I also have this week a bunch of little updates. The first is Ball Wall TM. I'm so happy about this. Finally, my desk is free of balls. Ever since I bought those Norwick juggling balls, like the ones that Jugglebot's actually using with like the sand or whatever it is in them, I've had like 6 or 7 of them on my desk here, and I'm always just moving them out of the way to do different things, and it's so freaking annoying. But now, with some of the, oh my goodness, that one, with I've found a small area of wall space. Why is that slipping? Oh, don't do this now. What are you doing? This is literally the only time this has ever happened. All right, now I want to show you. I'm lifting that up by hand. Why do things choose the most annoying times to not work? Oh no. That's so weird. It's just slipping. All right, bear with me while I roll this up like a pleb. And I shit you not, I've had these up for like, I don't know, a while. This has never happened before. But hopefully you can see there. Is that going to stay up? Yes. Ball Wall! God, the slowest reveal ever. Yep. So now I have all of my balls, well, all of Jugglebot's potential balls on display. We've got all of the marker balls. We've got this one that is the sketchy marker ball from the first tape that I tried. We've got the only remaining Norwick ball that is not covered, some other extra backup balls, and then the LED ones. They're all here. And I'm a big fan of this. And I know that I did say that I didn't want to drill more holes because I'm renting, but it's in the cupboard, so they're not going to care, surely. Stormy says, the difference between the 2 camera angles revealing the retroreflectiveness is wild. Interesting. Actually, yeah, you can see even as I've got a light right here next to the camera. As I cover and uncover that, I find these balls are so strange. Like, look at that. I can cover the light up from the ball's perspective. They're so weird. Like when they were sitting on my desk here, like I would be like out in a different area of the house and just like look into the room, and you can just see like the whole room here is just black, but you can see these like glowing balls, like spheres. So bizarre. But yes, Ball Wall is there, and it's so good. Like I can just cover it up when the bloody screen works. I need to cover up this area anyway, because further up here I've got the retroreflective tapes, and there's all like metal stuff in here, and these sometimes catch the cameras and they make errors. It's like I'm gonna have this down anyway, so now they're all kind of tucked away, and it's so neat. I love it, big fan. Yes, I also finally actually did the backup of Jugglebot's computer. It is now on this drive here. This is something that came up a while ago, and I'm interested to know actually if people... I feel like I kind of gave the impression that I did it before, but I never actually said that I did. I was looking into it and I was trying to do it, and it was confusing. And honestly, doing it yesterday was stressful as it was not mounting my drive. Mounting drives in Linux, why is that so hard? Why don't you just plug it in and it's like copy files over? Like, it was a whole thing. But it worked, and now I have it on here. And I did it like a very, I don't know, basic way where it just copied the entire contents of Jugglebot like SSD onto here. So even though that SSD is like, I've only used like 70 gig, I think, out of like 250, it's still, the copy is still 250 gig, which doesn't really matter because I'm not using this drive for anything else, but yeah, it took a while. But now we actually have a backup. So now if I break that computer or like spill water on it or something, or like, I don't know, if somehow the SSD dies, we can actually go back again, hopefully. I do kind of want to actually test this and get another SSD and then flash it and like verify that I can actually bring everything back correctly. But I don't have another SSD to do that, so I'm just going to kind of assume that this has worked for now. Maybe one day I'll get another SSD and try it. But yeah, that's a big relief. It's good to know that that is actually done. Yeah, I'm very happy about that. Also, there was good progress this week on the Docker container for remote dev work. And all of the credit here is due to Joe, who's one of the guys on Zulip. And the idea here is that we will have a Docker container, which for those who don't know, basically just allows you to run different, I'm not super, I don't know, up to scratch with exactly what all this stuff does, but from my perspective, from my understanding, the Docker container just allows you to like run different operating systems irrespective of what your like main operating system is. Like for example, I'm currently running Windows 10 on my main PC that's doing all this streaming. So I can't easily reproduce, I can't easily do work as though I am on Jugglebot's main computer on my Windows 10 PC, because Jugglebot's computer is a Linux and they're not the same thing. So Joe has gone to, from what I can tell, is like a fair bit of work to make sure that this Docker container is working so that you can just follow these steps and then have an exact reproduction of Jugglebot's actual computer on whatever PC you're working on. So I believe right now it's like, I'm only really focusing on the Windows 10 aspect of it, but I think he's also intending on getting it to work for Mac, so that if anyone out there is like wanting to do some stuff, like wanting to either help on Jugglebot or just like to see how it works, then you can just exactly reproduce everything and just run like the ROS network, run the different nodes, like you can just play around with it. It won't obviously have the actual hardware attached to it, so I think a lot of things won't work, but once this side of the Jugglebot project gets a bit more developed, then I imagine we should be able to like spoof data. Or even now that I've got like the ROS bags working, we should be able to get those recordings. Like I can run a session and do everything, and if we want to, we can record every single message that has happened on that ROS network for the entire duration of that session, and then you can play it back. So you can play it virtually, like I could play it back on my Windows 10 PC, and there would be a section of it that thinks it is the Jugglebot computer and thinks that it's running the actual robot, but in reality, it's actually just a recording. So I think that'd be really, really, really cool. And yeah, I'm massively thankful to Joe for putting in the effort to get this working. It's super cool. Yoroka says, containers don't include a kernel, so whatever OS you run it on has to be able to emulate the kernel that the container expects to be running on. Interesting. Okay, so you can't run anything then. Yeah, okay, that's interesting. Okay. So this one is more of a, I don't know, philosophical, I guess, maybe. Let me have some water first. So, something that has come up a lot in this project is that there are always a million different things to do. Like right now, it would be productive for me to try different catching routines, like to see how I can tune the hand to get it to catch properly. It would also be productive for me to do the motion capture work that I just did. Honestly, there's like a lot of other things that I just can't remember off the top of my head because I haven't been focusing on them. But there's a lot of different ways that I can do stuff and have it be productive for this project. And a big factor that plays into what I'm deciding as being the best way forward, and yeah, a big factor for that, which I don't recall explicitly talking about before, is just doing what I am most keen on in the moment. This does lead to a bit of flightiness, I think is one way that it could be described. And I think that anyone who's been following this project for a while might have thought this at some points. Like, for example, I was doing a lot of work on the camera moving rig a little while ago. That's definitely still plans to do that, and I was really keen on doing it for a little while, but then my interest moved on to something else. And now I'm where I am right now. And yeah, honestly, I have a very strong feeling that doing what interests me the most on any given day, let alone like a week or like a longer period of time, that is the best way forward. Because if I am, there have been quite a few times where I've been working on something and then I've thought like, oh, I really want to work on this other bit of Jugglebot instead, but I need to, for whatever reason, like this other, like first thing has to be done first in order to get to that other stage, or it's like more important or whatever. That drives, I don't like doing that. I hate having to work on something and having in the back of my mind like, oh, there's this other thing that's right here. It's literally, all of this stuff is within arm's reach of me in this room. I can just change and work on something else instantly. And like, it's there, ready to go. And like, there's so many, like, I've got all these compliant mechanism things here still. Like, this is an area of like interest that I am keen to explore more, but haven't had the time. And yeah, so I'm a big advocate for doing what you are keen on, and that's a huge part of why I'm making a lot of the decisions that I am with how to move forward. The reason why I'm bringing this up now, there's two. One, the first is that last week I mentioned that partner juggling is, in my opinion, going to be one of the faster, I'll amend it to that, ways of getting Jugglebot to juggle. And a big part of the reason why I feel that doing partner juggling, where like I am one hand and Jugglebot is the other hand, a big part of the reason why I feel that that is a good way to move forward and one of the faster ways to move forward is because I'm really keen on getting that working. And when I'm really keen on getting something working, I'm a lot more motivated to get it to work. Versus having Jugglebot juggle purely by itself with no interaction from me, I think that is also a very valid way that it can learn. And to be honest, the fastest way, like, I don't know if that really means much, or like can mean much, but yeah, that's a big reason why I am super keen on getting the partner juggling working, is just because I am very, very, very keen to have that work. I think that would be so much fun to have that work. The second reason why I'm bringing this up now is because this last week I have been fortunate enough to be able to go juggling myself a lot more regularly. Normally I'm only going like once a week maybe for like the last 6 months or so, and that is not regularly enough to get better, especially with 7 balls. Like, I really want to get my 7 balls good. I really, really want to be able to do 50 catches of 7 balls before Jugglebot can. I think that'll be so good. But the only way that I can do that is if I practice all the time. And so this week I have been pretty much every day I've gone out for my own juggling sessions. And one thing that happens when I juggle more is that I become more keen on not having to bend over and pick up the fucking balls off the ground. This is so annoying. I've got a friend who juggles, and he mentioned that he doesn't really face this problem. He's like, yeah, I've heard, like, I know you complain about this a lot, which I do, but for him, it's not really that big of an issue. I think that this is something that happens more as you progress higher and higher in the numbers. Like, I spend a lot of my time on my juggling sessions doing 6 and 7 balls, and I've been getting some really long runs of 6 actually. I'm pretty happy with that. 7 is getting there, but we'll see. But the problem with when you have more balls is that A, you're throwing them higher, which means you're putting more energy into them. You're giving them a higher velocity. So if your throw is just a little bit off, instead of landing like 30 centimeters to your side, it's going to land like 3 meters somewhere else if your throw is far off. But like you can't throw 3 meters away. If you're only juggling 3 balls, there's no way you can throw the ball accidentally 3 meters away unless you're like, I don't know, you trip or something. Yeah. But not only can you throw them, like, are you giving them more energy, but also there's just more of them to collide with each other. And so with 3 balls, you can't really, like, you can have a collision, I guess, but like it's only ever going to be between 2 balls and they're not going to have much energy and they're not going to go very far. But if you're doing 6 balls and 2 collide, well, it's pretty damn likely that that's also then going to collide with another one or even another one. And then they all just kind of, and then, so rather than like going down and picking up like 1 ball, instead you've got 1 ball over there, 2 balls over there, and 1 ball like 2 meters behind you. And you've got to kind of just walk around just, and pick them all up. Freaking annoying. I hate it. So, all of this to say is that I have a renewed interest in, especially if I'm going to be juggling more and more regularly, which I hope to, especially now the sun is setting later, which is so good. I have a renewed interest in building a ball butler, which is the name for a little robot of some description. There's many different ways to get this to work, but some robot that I take with me juggling to the park when I juggle, and whenever I drop a ball, it can pick up the dropped balls, and then when I give some indication to it of some form, it could just be as simple as like a Bluetooth button or something, maybe to start with it will be, but I think at the end goal, having like, I can just do like a hand gesture to it, and then it will throw the ball to me, so that I don't need to bend over and just destroy my body ever again. It would be glorious, it would be great. That is obviously a little while off. I haven't done any, well, I haven't done anything on that in a little while, at least. But there are things that we can do now that will kind of move us towards there. So, all of this to say, I have some thoughts on Jugglebot's primer, which is the device that will introduce more balls into Jugglebot's hand. It's obviously fairly easy to start it off with 1 ball. I can just put the ball in the hand. But then if it's doing 2 balls or even more balls, then it becomes very difficult to load, to like get those other balls into the system. And if you've seen my last like proper video, you'll know that the way I was doing it before that video was to just sit there myself and just time it and just put the ball in. And that had a reliability of like 10%. It was not good. So we need some other way to get the balls into the system. And we've had all sorts of different ideas. I think the simplest is to have, I just realized recently that so these racks that these paper rolls are on, they've got the white one behind, the black one here, and then I've got a third rail here. So I could, without too much effort, I think, put a rail along here and then have some kind of like dropper that just drops the ball in. And that's a pretty perfect spot to do that, in my opinion. Like that's almost too good an opportunity to pass up. However, I'm pretty interested in passing it up because my thought from ages ago of how we can do this primer is to have basically the same mechanism that makes up Jugglebot's hand mounted to some kind of mechanism that can move it around and orient it. And then we can say to this primer, we can say, hey, throw the ball to this position, well, throw the ball so that it lands at this position at this time. And then it can just do that. That is obviously significantly more complicated than just getting the thing to drop the ball down. However, if we get this to work, that is like 50% or even more. I mean, percentages don't really work for this sort of thing, but it's a very large part of what would make up the ball butler robot, which can return the balls to me when I drop them. So I'm very, very interested, I'm very motivated in getting that solution to work, even though it's way more complicated than it needs to be for this specific job. It will lead to other things down the line, which I have a very strong interest in getting to work, or very strong motivation in getting to work. So I'm back on the throwing the mini Jugglebot. I'm not going to spend, for now, I don't know, we'll see. I'm not planning on like dedicating too much time to getting this to work, but we will at some point need a mechanism to get the extra balls into Jugglebot, and I really want another mechanism to get the balls back to me. In my mind, this feels like a very good pairing of things. So yeah, as I said like 5 or 10 minutes ago, I really like choosing, well, I didn't say it exactly this way, but I really like choosing what I do on any given day, just like in the morning. Or if usually I have things that are like multi-day procedures, like all this Mocap stuff was like a large part of this week. But I wouldn't be too surprised if I end up spending a little bit more time in the coming weeks to get this kind of like directional launcher thing primer working properly. I think it would be so good. And so much cooler than a dropper. A dropper's a bit lame. Bit lame. Yep. Thank you for coming to my TED Talk. Yes, so Emmanuel Mess says, Docker really helps to keep the system replicable and working across computers. Yeah, I think that's the big part of why Joe is pushing for this as well, because it means that when people are doing this kind of development on multiple computers, everyone's seeing the exact same thing, and it's very, replicable, repeatable, yeah. Okay, some other Misc updates. I got a funny email earlier this week from a recruiter for America's Got Talent, which is kind of interesting that I'm not really part of America. Yeah, which was pretty cool to see. So it was what you might expect it to be. It was like, hey, like, we are doing the recording for the next season. Are you like, is Jugglebot is it stage ready, and would you be keen to participate? And I said, like, this is pretty like unexpected, I guess, in some ways. And unfortunately, Jugglebot is very, very not stage ready at this point, especially because they said that the recording will be going on in March of this year. Like, there's no chance Jugglebot is going to be remotely stage ready by March of this year. But in the future, maybe. And I also asked him, like, just out of curiosity, would I actually need to be part of the performance? Because in my mind, especially for like, if Jugglebot's going to be performing, it's going to be so much cooler with no humans involved. Humans is, I think once Jugglebot gets to that point where I'm saying like, yes, it's good to be in a performance, it's going to be way more accurate than a human is. And so like introducing a human is just introducing chances of error. So I don't think it's, yeah, I was curious to know. It's like, I don't really follow America's Got Talent or like any of those shows, but like all of the snippets that I've seen, it's always people doing the performance, right? It's not really like, America's robots have talent. Like, they can't just get like Tesla bots out there to do their like teleoperative dance, which is such cheating. But apparently, so his reply to this was that like, he said it would have to be, I can't remember verbatim what he said, but it was like, humans, what was it? If Jugglebot is like spectacular enough, then it will be fine. But it has to be like, it's a very high bar for a no human performance. Apparently they had a drone one recently that went pretty well, which if I can find a link to it, then I'll put it in the description, but I only got that reply like this morning. But yeah, apparently there was a drone performance that had no humans, and that was quite good. But yeah, usually they want people involved. But it'd be pretty funny if Jugglebot could win America's Got Talent, just robots. It's like, what does that mean? I feel like it's a very existential thing for a lot of people. It's like, robots are taking our talent. It'd be pretty funny. Yeah, Stormy says, introduce a human as a comedy routine. Yeah, like a magic show of sorts. And John says, yeah, I agree that Jugglebot needs a human element for a great juggling show. I think it depends. He says, obviously it'll also be key to show off the spectacular stuff it can do. I really, really think it depends. I have spent a lot of time thinking about where Jugglebot can go, and honestly the only reason why I'm still doing this project right now is because I know where it can go. And I'm fairly sure that I've never heard of anyone talking about juggling being presented in the way that I'm hoping that it will be done with Jugglebot. I think the juggling can be so much more than what humans are capable of. Like, yeah, and I really think that like the best, it depends what you mean by best, like definitely for comedy's sake, like it'll be pretty hard to make a comedy routine with just the robots. I think I 100% agree on that. Like a human could add a lot of layers to that side of things, but just from like a pure, like, I don't know, like an observatorium where they have the light shows and that sort of stuff. Like, I think on that level of like, wow, this is impressive, I think no humans are necessary at all. I honestly think humans would muck it up. I also, there's I think this is a good time to mention this now. Actually, I've been thinking a lot about like what the best format would be in to like view a Jugglebot performance, and I think the best one that I've come up with, the best one that I can think of for now, is to have. I don't know how to like. This does not scale at all very well, but that doesn't really matter for me. If you imagine sitting on like reclining chairs with like maybe 6 or 7 people, all like head to head, so like your feet are kind of like you're like a star with like heads in, feet out. You're kind of like sitting there in a position where you can see down, but you can also see up pretty easily. And having a ring of Jugglebots all around, potentially multiple layers deep, and then they can do stuff just like between the neighboring Jugglebots, but then also they can throw over you, over all of the humans, to the ones on the other side. I think that would open up so many very, very, very cool things that like no one's ever seen before, because you can't do that with humans because we suck at juggling. I think that'd be pretty damn cool. Honestly, anytime you're like listening to like a really beaty song, just imagine like balls in that exact pattern. It's so hard to describe what I'm imagining. But we'll get there. One day you'll see it. Eventually. Cool. One other mini Misc update is that last year we were talking about different ways of making the balls retroreflective. And one of the more outside the box suggestions was to crochet a little sleeve for the ball to go into, so that this string, which is retroreflective, can wrap around the ball and cover it up. And as you can see, I haven't really gotten very far with my crocheting. I'm only bringing this up now just to like kind of continue that thread, because I said that I'll do it over the Christmas break, but I never did because my brother's printer wasn't working, and he wanted me to fix it, but I'm like, I don't want to fix it, you can fix it, and it just never got done. And yeah, so it turns out I need to buy proper crochet hooks, because the printed crochet hooks, even printed with my printer, they did not really work very well with this. So I need to get proper ones, and I might try the monkey's fist that someone was suggesting, but honestly, like that is like a super low priority for me, and that's just going to be like if I am in the right mood and I'm like watching a movie or something, then I can just make steady progress on that, but I don't see that changing anytime super soon. I do really, really like that idea though, and I'm very keen to try it out, but yeah, we'll get there. Yes, the last thing is sound working now? So last week the sound wasn't working, but I want to check, I just want to make sure that it is for later. And if it is, you should be able to hear people celebrating. So hopefully you can hear people celebrating. Hopefully. Yeah, OBS was being a bit funny, but it should be working now. Cool. Okay, that's pretty much everything. Yep, lots of stuff. I really hope that this mocap marker stuff is working better. Actually, all right, there is one more thing that I didn't have a slide for because I'm a fool. But that is that I've now added, you would have seen this as the spoiler before, but I've now added markers onto Jugglebot's platform. So if we go to here, how good is that? I mentioned last week that I wanted to try wrapping tape around the bars. So like here on my conductor's wand, I've added the tape sections onto here, and this works really, really well for the cameras to track. So I went around and added those tape strips onto the platform here. And so now we've got like, there's 11 of them in total, and they're all around the place. However, I did all of that before I made the, discoveries that I did with regards to the motion capture software. So I might actually need to move them now. The reason why I might need to move them is because, for the same reason as when we're tracking the base, we want the centroid of those markers to be at a known location on the base, at least, like ideally at Jugglebot's actual centroid. I believe the same thing applies for the platform. It would be easiest if we could position markers around the platform so that the centroid of all of those markers was at a known position. Ideally, it would be like, I'll show you on the CAD. this guy. Yes, let's show everything. Why is a sketch an instance? I don't want sketches. I really wish Onshape had like a hide all sketches thing. That'd be good. Yeah, so ideally, the centroid of all of the markers on the platform would be right at that same like 0, 0 point. Because we went to like a not zero amount of effort to make sure that the hand is directly in the middle. And we would be really good if we can just take all of this platform, take like the centroid, like take the origin of where the tracking software thinks the platform is, and just say, yep, that's where the center of the platform is. That would be so good. And as we can see right now, I mean, it's a bit, we can't actually like, we can't overlay this onto the CAD or anything, but these markers, where they are right now, are very front heavy. So let me actually put this origin bit on. So yeah, this unlabeled marker here, this gray one, is where the centroid of Jugglebot is. And we can see the center of the platform, which is this coordinate system here, is still pretty far forward from that. So yeah, it's tricky. I don't know, I don't really know where to put the markers, and this is something that I'm going to talk with the guy tonight about, but I don't really know where to put the markers on the platform because I don't trust that the platform is exactly the correct geometry. Like the geometry that we have on the CAD is all well and good, but when I assembled the platform together, I'm almost certain that not all of those carbon fiber rods went all the way into the to the 3D printed parts. Like there might be like 0.5 millimeter gaps in some of them, and they're all like very solidly glued in now, so they're not moving. And like, yeah, so I don't trust that the platform geometry is correct, which makes it tricky to tell my software where the markers actually are. Because I can measure, it's like, okay, from, I don't know, this part of the printed part to the marker is 10 millimeters or something. But in reality, if the marker is where it actually is, then that distance might supposed to be 11 millimeters or something else. Like, it's really, yeah, I don't exactly know where to put these markers to get the information that I want. I think that I want the centroid of those markers to be at like that 0, 0, 0 point. But even if that is the case, where do I actually put them? Because the platform, like the carbon fiber rods are not symmetric. Like they've been skewed off to the side to make sure that the hand is directly in the middle here. So it's a bit tricky. And maybe we can get away with not actually tracking the platform at all and only tracking the hand, which is why I've made this version of the hand that's got little cutouts the whole way around, and I actually printed this off, and honestly the print quality is kind of meh. It's not the best, but it works, I guess, maybe, I don't know, see. But yeah, it's got all these little cutouts around the side, and the intention there is that I can wrap tape around each of those little cutouts, and then we can know exactly where the hand is. So maybe we only need to track the hand, and then we can infer, based on where the hand is, we can infer where the platform is. Maybe. I don't know. All this tracking stuff is not trivial. You've got to be, definitely requires a bit of setup. And I'm very glad that I've got this meeting with the guy tonight, because hopefully he can kind of set me straight. Because I've just kind of been like fumbling around, doing my own thing. And evidently I was doing some things wrong. So hopefully that gets fixed. Yes, that's my last update. Cool. Okay. Hope you found that interesting, as always. I don't really know what the update will be next week. We'll see. I'll be doing, like, I'll absolutely be screwing these mocap things on today and seeing if that works. And yeah, hopefully that does. And then hopefully we will soon be back on to getting the catching a thrown ball working. Well, like first off, like catching the dropped ball and then catching a thrown ball. Actually, one big thing that will need to happen soon is that the fact that when we move the platform around, it probably is not going to where we expect it to be going to. That's something that really needs to be addressed. And that's a big reason why I was interested in these motion capture cameras in the first place. The idea here, I think, for calibrating this, and this is actually a good reason why it would be good to track the platform, is that if I tell Jugglebot, move the platform 50 millimeters in the X direction, it will do that. It will think that it's done that, at least. But then if we can get the feedback from the cameras, and the cameras say, hey, actually, the center of the platform is not 50 millimeters in the X direction, it's actually 52, and also 1 millimeter in the Y direction, and also it's tilted a little bit, we can hopefully, well, we should be able to get Jugglebot, get the platform to move around into all sorts of different positions, and then we can take like a snapshot of where Jugglebot thinks it is, and then where the cameras think it is, and then have some kind of mapping of, okay, like one way to do this would be to have this mapping of, we can say, okay, we want to move over to here, and we know that if we just give you that raw input of like move 50 millimeters in the X direction, that that's going to be incorrect. So now we say, we like apply like an offset to each different point that it's moving to. So we can say, okay, if we're moving over here, we know that we need to compensate for the error in the way that the platform is made by moving it, instead of just saying 50 millimeters to the X, we're actually telling Jugglebot to move 49 millimeters in the X and 1 millimeter in the Y, and also the opposite tilt. And then it should move exactly 50 millimeters in the X. That's one way to do it. That does mean that every single command that we tell Jugglebot to move to, it's going to have to like reference like a lookup table of some sort to figure out what offset is most relevant for where it's moving to. And this also doesn't even address the fact that that's only static positions. Of like, if we tell it to move 50 millimeters to the X and then stop, that's going to be very different to, we were negative 50 millimeters in the X, and now we want to go 50 millimeters positive in the X, and then straight away move somewhere else. Like, how far off is it when it's moving dynamically? That's going to be a whole other thing to test, and that I think will be a lot trickier. So one way is to have that lookup table. A second way to correct for these manufacturing errors is to do what this paper did. That I'll put a link in the description for this paper at the end of the stream. I didn't before because I wasn't really planning on talking about this, but here we are. Yeah, there's a paper that someone found where they noted that small geometry errors in the platform can make the platform, small geometry errors in the construction of the whole robot can mean that the platform does not go to where you think it is by like a large error margin. And in this paper, they did that process that I'm describing, where they moved the platform around to a whole bunch of different positions and then took readings of where it actually is. But rather than creating a big lookup table from this data, instead, they took that data and they said, okay, what geometry of the robot will mean that when we tell it to move to these particular positions, it will actually move somewhere else. And they basically just like ran an insane number of simulations to figure out what geometry the robot is actually constructed out of. And this takes a fair bit of data because there are 42 different unknowns that affect where, there are 42 like geometry points that, or like dimensions that affect how this platform moves around, and they have to all be spot on. But in the paper, at least, they were able to do this, and it worked really well. Like, it cut the error down from like 15 millimeters in their case of platform position error down to, I can't remember off the top of my head, but I think it was less than a millimeter, I think, from memory. And that works really well. And that means that the end result of that is that rather, like in my code, I have I can show you actually. I have a node called, where is it? Jugglebot geometry or robot geometry. There it is, robot geometry. And in here, I have all the different dimensions of things. And we go through and we figure out where all of the different nodes are. So like where all of the base nodes are, assuming perfect symmetry. And so yeah, you can go through this as robotgeometry.py, and it figures out where everything should be, assuming that it is where it's supposed to be according to the CAD. It's almost certainly not that. So using the approach that the paper outlines, they basically replace this code with like hard-coded, like, okay, the base node angles, they're not all perfectly symmetric. instead of all of this like procedural stuff, they just have hard-coded base node 0 is here, base node 1 is here, and that's just where they are, because that's where we figured out that's where they need to be to get the platform to behave in the way that we're measuring it to behave. I really like that idea, because that means that we don't need to like reference a lookup table every time we move the platform. We just tell it, move here, and it will just move there. So it feels like it would be a lot more difficult initially to like run those simulations and then figure out what geometry the robot actually is. But once it's done, then we know where the robot is, and we don't need to worry about this correction ever again. It's just done, unless I like move stuff around. So yeah, I really like that idea. I think implementing what the paper's done will require a bit of ChatGPT work, and yeah, it's a bit outside my current level of understanding, but you know, that's also what most of this project has been, so it's nothing new, I guess. Euroka says, it sounds like they might have assumed that all of the joints don't have much slop. Yes, that's definitely true. Their robot was definitely not made by me, let's put it that way. It was a pretty legit robot. However, now that we've made all of these different improvements to the robot, like the joints actually do have very little slop. Like, definitely less than a millimeter or so. Like, these platform ones used to be really bad. Let me actually put you on this view. Yeah. Like, these joints here used to be a lot worse, but now, like, I can't move that really much at all. Honestly, the biggest point of slop is in the legs. Let me zoom out a bit. Once my remote turns on. This remote doesn't have like a battery indicator, so I don't like leaving it on. But yeah, so down here, I can like wobble this around quite a lot, and that's presumably not great. But interestingly, as long as I don't like if I shake the whole thing, then yeah, the whole thing's gonna shake. But this actually doesn't affect the end result of the platform at all. Like, moving this doesn't do anything. So I'm not really worried about that kind of slop. The slop in these joints, as I said, these are solid. The base joints, they've got like a little bit, but not much, because those are, I don't know if I have any extra ones, but those are really solid, like just ball, like magnets. It's just like a ball in a cup, and those are very, very strong magnets. Like I can't pull those apart. So yeah, I think that the slop is not that bad. I'm a lot more confident that things are not exactly positioned where they're supposed to be. Like, there's just like a gross like offset of where things are. And it's possible that like this slop is definitely a real thing, and it is more than, I'm assuming it's more than what they had in their robot. However, I think if we can run this like simulation, calibration setup, whatever we want to call it, it may not get exactly spot on to like if we have this geometry, then the robot will behave exactly how we've recorded it. That may not be the case, but I think we can get a lot closer than what it actually is. And I mean, honestly, like the cameras, like even directly after I've done a calibration, there'll still be like half a millimeter of error, of like residual in the marker positions. So we won't be able to get much closer than that. And I don't know how big of an effect the slop has, to be honest, but yeah, I think we can definitely get a lot closer to where we are right now. Yeah. Yes. But yes, lots of things to be done, as always. Cool. All right. Yes, as always, I hope you found this interesting, and yes, I will see you next week. Yeah, good luck with everything you're doing until then. Have a good one.